Hello everyone, welcome back to our YouTube channel. The topic to be discussed is on grouping of capacitors. From the previous lecture, we have learned that a capacitor is a device for storing a large quantity of electric charge. So in practice, the capacitor is grouped in two ways, that is series or in parallel. So here, first of all, we will discuss capacitors in series combination. Capacitors are said to be connected in series if a potential difference that is applied across their combination is the sum of the resulting potential difference across each capacitor. If we have three capacitors, say the capacitance of this one is C1, then this one it is C2, and then this one it is C3. Then V equal V1 plus V2 plus V3. Here, this V is the potential difference across this combination. V1 is the potential difference across capacitor C1. V2 is the potential difference across capacitor C2. And V3 is the potential difference across a capacitor C3. So one should be noted that when a capacitors are connected in series, the net capacitance decreases. So let us think this one to be positive, this one to be negative. So therefore, the charge that is given on this plate, it is plus. Here, it will be minus. Similarly, here, it will be plus. Here, it will be minus. Here, it is plus. And here, it is minus. So remember one thing, that in series grouping, the charge through each capacitors are same. So Q be the charge through each capacitors. We have learned earlier that Q is equal CV. In this case, the charge is Q. The capacitance, it is C1. The potential, it is V1. Similarly, in this capacitor C2, the charge is Q. Capacitance, it is C2. The potential, it is V2. And also, in this capacitor C3, the charge is Q. The capacitance is C3. And the potential is V3. As I have mentioned earlier, that in the series grouping, the charge through each capacitors are same. So if we substitute this value of V1 in this equation, from here we can see that V1 is Q by C1. Similarly, from here we can write V2 equal Q by C2, and from here we can write V3 equal Q by C3. So if this is equation 1, then equation 1 implies that V is equal to Q by C1 plus Q by C2 plus Q by C3. Then from here we can write V. We can take common Q. So here we can write 1 by C1, 1 by C2 plus 1 by C3. Then we can write V divided by Q. This one is 1 by C1 plus 1 by C2 plus 1 by C3. But what is this V by Q? This V by Q, it is equal to 1 by C. From this equation, V divided by Q is 1 by C. So, therefore, we can write 1 by C is equal 1 by C1 plus 1 by C2 plus 1 by C3. So this is the equivalent capacitance for a series combination. So now let us solve these numerical problems. The question says two capacitors, each of capacitance 2 microfarad, are connected in series as shown in figure. Calculate the net capacitance across the combination. So solution. Given C1 equal 2 microfarad, then C2, this one is 2 microfarad. So since C1 and C2, they are in series, so the net capacitance can be calculated by using this formula, 1 by C1 plus 1 by C2. So 1 by C, it is equal 1 by 2 plus 1 by 2. So this is 1 by C. So half plus half, it is equal 1. So this implies that C is equal 1 microfarad. This net capacitance, as we can see from here, it is less than C1 and also less than C2. As I have mentioned earlier, when a capacitor are connected in series, the net capacitance decreases. Here we can see the net capacitance is 1 microfarad, which is less than C1 and is less than C2. Now we will discuss capacitors in parallel combination. Capacitors are said to be connected in parallel if a potential difference that is applied across their combination results in the same potential difference across each capacitor. One should be noted that when a capacitor are connected in parallel, the net capacitance increases. So let us consider 3 capacitors. Of capacitance C1, C2, C3 connected in parallel as shown in this figure. Say this one is plus, this one is minus, this is V. So if a plus charge is given on this plate, the negative charge will be induced in this plate. So similarly here and here also. Remember one thing, for a parallel grouping, the charge through each capacitors are different. That is, if Q1 is the charge through C1, then Q2 will be a charge through C2, Q3 will be a charge of capacitor C3. So therefore, the net charge Q, it is nothing but Q1 plus Q2 plus Q3. So we know that Q equal CV. So here Q1 is equal C1 multiplied by V, and since these capacitor, they are in parallel, so the potential difference across C2 will also V. So therefore Q2 is C2V. Also Q3, it is C3V. So if we put this value of Q1, Q2 and Q3 in this equation, say it is equation 1, then this Q is equal to C1V plus C2V plus C3V. So this Q, from here we can take common V. So C1 plus C2 plus C3. This implies that Q by V equal C1 plus C2 plus C3. But what is this Q by V? Q by V is nothing but C. So C is equal C1 plus C2 plus C3. So this is the equivalent capacitance in the case of parallel combination. So now we will solve these numerical problems. The question says, two capacitors, each of capacitance 2 microfarad, are connected in parallel as shown in figure. Calculate the net capacitance across the combination. So here given C1 equal 2 microfarad, C2 also 2 microfarad. So the net capacitance across this combination can be calculated by using this formula, C equal C1 plus C2. So this C equal 2 microfarad plus 2 microfarad, and this C is equal to 4 microfarad. So as we can see from here, this net capacitance, it is 4 microfarad, which is greater than C1 and also greater than C2. So as I've mentioned earlier, when a capacitor are connected in parallel, the net capacitance increases.